Next one is a little more complicated. It uses a lot of science, so get ready for the physics behind this. So with a radio wave, that wave has a ton of energy behind it because it's a VHF wave, which is a very high frequency. Radars use VHF waves, and they have a lot of energy behind them. So to get rid of that, we use something called oscillation in the metalloids on the stealth technology on the plane, which goes under two separate things. One, you have this right here, which is going to be our free electrons. These free electrons happen whenever you have an atom with too much energy and the electrons break away from the parent atom. And then underneath of it, we are going to have our positive ions. Our positive ions and our free electrons are held together through electromagnetivity. Now these create a sort of lattice together. So that way whenever VHF wave hits this, it spikes these up. These get a ton of energy, and whenever these get a ton of energy, these don't like that, because these two right here want to equalize. Not one wants to be hotter than the other, because whenever energy hits it, it creates kinetic energy, heating it up. Heating this layer up, which then it disperses this energy into the bottom layer. So this energy now disperses between this layer. They'll disperse this radar wave's energy between the two. So that way, whenever this radar wave comes back out, its energy is no longer as much. Whenever the VHF wave hits the free electrons, it disperses its energy to the positive ions, which then in turn go back and forth between the two layers, equaling out the energy between the two. By the time it comes back out to the radar, the energy that comes back out is very, very low and is undetectable.